This section explains the factors to consider when you select analysis and visualization tools. Throughout this course, you learned about the layers of a data pipeline. Raw data makes its way through the stages of the pipeline: ingestion, storage, processing, and analysis and visualization to produce insights about the data. This simplified diagram illustrates where analysis and visualization is in the data pipeline. Although each layer is distinct, how data is analyzed and visualized is tied to how it is stored and processed. Data engineers focus on the infrastructure that the data passes through. This three-part framework will guide you through the questions that you need to ask and the factors that you should consider when selecting data analysis and visualization tools and services. To build the correct pipeline, it's necessary to fully understand the desired outcomes based on business needs, the characteristics of the data, and who needs access to analyze and visualize data. Keep the end goal and business need in mind as you design the analysis and visualization layer of the data pipeline. Which analyses are needed to develop insights? What insights can be pulled from the data? What visualization would illustrate the insights? Does the customer need to generate a report or interact with a dashboard? The granularity of insight relates to the level of data that one has access to. A finance manager has access to data for their line of business, whereas the chief financial officer has access to all the data. Consider the grain size of the data that needs to be analyzed and visualized. Is it at a detailed level or an aggregate level? A key aspect of getting insight from your data is finding patterns. The right visualization will help you gain a deeper understanding of the patterns in your data in a much quicker time frame. Visualizations highlight one of the following 5 types of insights: key performance indicators, relationships between 2 variables, comparisons of variables, distributions of data, and compositions of elements that make up your data. As you consider the characteristics of your data, consider the volume, velocity, variety, veracity, and value of your data. How much data is there? At what speed and volume does it arrive? How frequently is it updated? How quickly is it processed? What type of data is it? Using the 5 V's as an overarching framework, consider what types of data you are dealing with: historical analysis or streaming IoT data, structured, semi-structured, or unstructured data? How will the data be visualized? In a periodic report or an interactive dashboard? For a fraud detection use case, consider the business needs first. For this purpose, 2 use cases are shown as examples here: rule-based fraud and machine learning in real time. Next, consider the characteristics of the data by asking questions. Rule-based fraud detection takes a reactive approach and provides a historical reporting of fraud cases. Structured data is ingested, analyzed, and reported in predefined intervals. In contrast, the ML fraud detection example takes a proactive approach. It provides the ability to detect fraud in real time as millions of transactions go through the streaming pipeline. Keep these questions about access to the data in mind as you select analysis and visualization tools. Where does the data come from? Will the data need to be combined from multiple sources? Who needs access to the data and at what level? Who can access the tools? Based on the principle of least privilege, a user's authorization to access data depends on their role in the organization. Consider this as you think about selecting tools and services to analyze and visualize data. For example, a business analyst or manager might be authorized to read the output that data engineers or data analysts create, but not delete or update it. An analyst could work with a data engineer to query data and be able to perform interactive analysis by using Amazon Athena. Domain experts and business analysts could ask questions and explore the data with a data analyst or data scientist to create a visualization by using QuickSight. A team might not include the roles with these specific titles shown on this slide, but someone on the team is likely performing the same functions. Here are a few key points to summarize this section. You learned about 3 factors to consider when you select tools to analyze and visualize data. For business needs, consider the granularity and format of the insight. For data characteristics, consider the volume, velocity, variety, veracity, and value of your data. For access to data, consider the functions of individuals who will access, analyze, and visualize the data.